copy the home play for tonight. Home play, it's only 6 problems. The first 2, it says represent 4 ways. Number 3 says simplify. Number 4, 5, and 6 is multiply or divide. And in case you don't see this, look at number 6 up on the screen. The 9 has a negative right in front of it. Everybody see that? So that you don't forget to put that negative. Okay, copy that, please. Night. So, our objective for today, I can multiply and divide real numbers. Let's read together. 1, 2, 3. I can multiply and divide real numbers. So, once again, that goes on the bottom left of your Cornell notes. Yes, sir? Yeah, the one that you started today, right? And we already have the Ferrier model for the real numbers. Is that correct? You did that on your own, and you know this by memory? Damn, you guys are pretty good. Steps. Write these steps underneath, please. It says to multiply and divide real numbers, step number 1, identify if the result is a positive or negative. Identify if the result is a positive or negative. In parentheses, write if both numbers have the same sign, the result is positive. Now, the reason why we're starting with step 1 being this one, identifying if the result is a positive or negative, because if you reflect back to your mathematical career before 8th grade, it probably happened to you maybe once that you were taking a quiz or a test, and you left really confident that you got 100%. And all of a sudden they give you back the results, and you saw that you forgot to put the sign on an answer. And let me explain why. Because your noodle was worried about the computation, and at the end you forgot about the sign. And what I want us to start thinking about is thinking about the sign first, whatever the solution to the multiplication division. Focus on that. And that's why step number 2 would be compute the numbers, which is multiply or divide, and at the end you're going to simplify. I don't want you guys to do the work first, because if you do the work first, sometimes we tend to forget. Okay? Copy that. Okay? So 3 easy steps. Number 1, identify if the result is positive or negative. The only rule that you need to remember is what? If they have the same sign, the answer is positive. And obviously, if they don't have the same sign, the answer is what? Negative. Okay? From there, you compute, which is multiply or divide, and at the end, simplify. Okay? So before we move on, let me show you really quick what multiplication looks like using tiles, number line, and area model. So copy this down, please. Yeah, you need to turn your paper to the back, right? I want you to write tiles, number line, and area model. And we're going to show 3 parentheses for multiplication times negative 2. Okay, first I'm going to go on this side, and I'm going to show it using tiles. To show this using tiles, we start with the factor that's inside of the parenthesis. What factor's inside of the parenthesis? Negative 2. So I'm going to use negative 2. There it is. And the leading factor is what tells me how many times I'm going to repeat that group. How many times? So that's 1, that's 2, that's 3, and what do you see? Negative 6. The second way, I'm going to use a number line. Draw a number line right here. We're starting from 0. And once again, we start with the factor, which is inside the parenthesis. What factor is inside? Negative 2. So the very first jump from 0 is to negative 2. Did I go -1, -2? No. It's a straight jump to -2. How many times am I going to do that jump? 3 times, because the leading factor tells me that. So that's 1, that's 2, and that is 3. And the last way of representing this would be with the area model. I want you to draw a rectangle. And I'm going to put the whatever's inside the parentheses up here, -2, and the other factor right here. To find the area of this rectangle, first we start with the symbols. Are they the same sign? No, so the answer is negative. Now we do the computation. 3 times 2, that is 6. Very simple? Yes? Okay, let's do another one. Let's do 2 times -12. I want you to do the tiles. I want you to do the number line for that one. And I'll go over the area model. Don't go ahead of me so I can show you one more step on that. I'll give you some time to do that. Copy that and go. Pokemon Go. All right, let's see. Using tiles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. How many times? Twice. Is that 12? Oh, I put 1 extra. So the total is -24. With the number line, fairly simple, the same thing. The first jump should be at -12. How many times do we do that? Twice, and we land at -24. Okay? For the area model, this is what I want you to do. Draw the area model, a little bit bigger. And for this one, since it's a 2-digit now, I want us to split this up. We're going to write it like this. -10 plus -2. And the other factor goes in the front. Since now we have 2 digits here, we need to divide this into 2 different areas. Straight down like this. And now we have one area right here and another area right here. Do you guys see it? Therefore, are these the same sign? No, subtraction. So therefore, 2 times 10, that's 20. Okay. Are these two the same sign? 2 and -2? No, so it's negative. So what is 2 times 2? 4. Are these the same sign? But since we're no longer multiplying, we're combining, so now we end up with -24. Okay? I just wanted to show you some, yes. Oh, some applications to representing it using tiles, number line, and area model. So, what I do want us to focus today, I wanted to show you how to, or why is it that for division, we end up doing something that you learned since elementary, and we'll see that right now. Look up to the screen really quick. So watch. Copy these, please. Example 1A, B, and C. And these are a piece of cake. We're not going to do this using 3 different ways. What I want us to use is the steps that I gave you to multiply or divide. So it says, example 1, find the value of each expression. 1A is 35 divided by -5. 1B is -11 times -4. 1C is -6 times 7. So for 1A, are these the same sign? No, so the first thing you should have done is written the sign. Now we focus on the computation. 35 divided by 5, that is 7. Let's go to 1B. Are these the same sign? Yes, so therefore the solution would be a positive. 11 times 4, that's 44. Are these the same sign? No, so therefore it's a negative, so 6 times 7, that's 42. And that's how I want you to start thinking from now on. Do the sign first, and then do the computation. Everybody there? Okay. All right, so, piece of cake, copy these. Example 2, A and B. You don't have to copy the instructions anymore. They're already, we already wrote on the previous ones. Example 2A is 1/2 times negative 10, and B is negative 48 divided by negative 4. So let's see if you remember from previous years. When you multiply a fraction times a whole number, or I'm sorry, times a integer, what do we make this? We make it into a fraction by writing over 1. Therefore, are they the same sign? No. Therefore, 1 times 10 is 10. 2 times 1 is 2. 10 divided by 2 is 5. All right? Are these the same sign? No, Mr. Q. All right. Oh, yes. Okay, my bad. So it's a positive. 48 divided by 4, that is 12. Piece of cake? Yeah, right? All right. So we're done with those. One thing I'm going to talk about right now is the reciprocals. Reciprocals are two numbers that give us a product of 1. For example, if I have 4, the reciprocal of 4 that would give me a product of 1 is 1/4. The reciprocal of 2/3 to give me a product of 1 is 3/2. The reciprocal of 1/7 to give me a product of 1 would be -7, or -7/1. Everybody following? Okay. Now, I wanted to talk about reciprocals because of this next definition. Look up, please. This definition is the definition for rationals. And it says, a rational number is the set of all numbers such that m over n, which means they can be represented as a what? What does this look like? A fraction. Such that m is an integer, n is an integer, but n cannot equal to 0. So that means these two are what? Integers, but n cannot equal to. So in the past, your teachers have told you whenever you have a fraction that's divided by 0, it's undefined. Have you guys remember that? This is why, because of the definition for rationals. It says it on the definition that you cannot have n equal to 0. Okay? Therefore, if m is an integer and n is an integer, are we there? So now let me show you a situation. Pay attention, please. Hold the questions to the end. Look at this situation. We have 1 3/4 divided by 1/2. What does that look like if I write it as a fraction? Because division is a fraction, right? It should look something like this. But according to the definition, are these integers? Is this an integer? Some of you are like looking at it. I don't know what just happened. This is not an integer, and this is not an integer. According to the definition, in order for me to have a fraction, these need to be integers. So if these cannot be like this, that means I cannot have a fraction here. So how can I get rid of this fraction? Or here goes a question, an easier question. How can I make this equal to 1? The simplest integer. Talk it over with your neighbor. How can I make this into 1? I heard some of you say multiply times the reciprocal. And that gives me 1 right here, right? But whatever we do to the denominator, we need to do to the numerator. So what is this divided by 1? that. Is that correct? All right. But now look what just happened. This was our original expression, and look what happened now. What do you guys notice? Talk it over with your neighbor. What happened from here to here? And so you said they just switched the second number. That's why, I don't know if you remember in 5th grade, 4th grade, your teacher said keep, change, flip, or whatever the case. Did they explain to you why? This is why, because of the definition of rationals. You understand? They're like, kinda. All right, good. I'm not going to continue with that because we're running out of time, but I want to get to one of these examples. Copy this one, please. Example number 4. Divide -1/2 divided by -5/6. First of all, we begin with the signs. Are they the same sign? Yes. So the answer will be a positive. Okay? So, look at it. If it's division, it's a fraction. Is that correct? Could we have a fraction over another fraction? No. That means we need to multiply the second one times the reciprocal. So therefore, this is -1/2 times the reciprocal of -5/6 is what? -6/5. And that gives us 6/10. And we know it's going to be a positive. Can we simplify? 3/5. Okay? All right. Enjoy your home play, guys. Once again, leave your books at home. And on Monday, we start with the funner stuff. Yay. Have a good one, guys. Enjoy your home play. See you guys till Monday. Bye.